The question is, the general form of the complementary function of a differential equation is given by y of t is equal to at plus b into e power minus 2t, where a and b are real constants determined by the initial condition. The corresponding differential equation is 4 options A, B, C, D given. This is from engineering mathematics from the topic differential equation, subtopic higher order linear differential equation with constant coefficients. This is one more question. The solution is so given complementary function. Usually abbreviated as CF is y of t is equal to at plus b into e power minus 2t. Therefore, the roots of the auxiliary equation usually denoted by m is equal to roots are equal roots, two equal real roots. M is equal to minus 2 comma minus 2 are the roots of auxiliary equation implies AE auxiliary equation is m minus of minus 2 m plus 2. When we know roots, the corresponding equation is obtained by product of the factors m plus 2 into m plus 2 equal to 0. From this equation, we will be obtaining m is equal to minus 2 comma minus 2. So this simplifies to m square plus 2 into m, 2m, m into 2, 2m, 2 into 2, 4. So this implies m square plus 4m plus 4 is equal to 0. Therefore, the corresponding differential equation is d square y by dt square, where y is dependent variable, t is independent variable, because all options are in the form of y and t variables, plus 4 dy by dt plus 4y, and the right hand side any term with containing independent variable or 0, that is denoted by any function of t, f of t. So according, this is the answer, this is the differential equation required. Accordingly, the answer is option A. This is end of the question. The question is, let R and R cube denote the set of the real numbers and the three-dimensional vector space over it respectively. The value of alpha for which the set of vectors set 2 minus 3 alpha, comma 3 minus 1 3, comma 1 minus 5 7 does not form a basis of R cube is dash. This question is from engineering mathematics from the topic linear algebra, subtopic vector spaces, which is one more question. The solution is So let us denote the given three vectors by x1, x2, x3. Let x1 is equal to row vector 2 minus 3 alpha, comma x2 is equal to 3 minus 1 3, and x3 is equal to 1 minus 5 7. Be the three vectors of the given set, since the vectors do not form basis of R cube, that is three-dimensional vector. Therefore, the determinant formed by the three vectors is 0. Do not form a basis means the vectors are linearly dependent. Okay. Which implies determinant first vector first row 2 minus 3 alpha, second vector second row 3 minus 1 3, third vector third row 1 minus 5 7 equal to 0, which implies determinant can be expanded by first row or any column, any row. So expanding by first row 2 into deleting first row first column, remaining minus 7 plus 15, middle number minus into minus 3 plus 3 into deleting second column first row, remaining determinant, remaining elements minor, 3 into 7 21, minus 3 into 1 3, plus alpha into deleting third column first row, remaining 4 elements determinant, 3 into minus 5, minus 15, minus of minus 1 into 1 plus 1 equal to 0. So this is 2 into 8 16, 3 into 18 54, minus 15 alpha plus minus 15 plus 1 minus 14, minus 14 alpha. Is equal to 0. So this simplifies to 14 alpha is equal to 70. From this, alpha is equal to giving 5. So the value of alpha is 5. This is the answer. This is end of the question. The question is, let z be a complex variable if f of z is equal to sine pi z divided by z square into z minus 2, and C is the circle in the complex plane with mod z is equal to 3, then integral over C f of z dz is dash. 4 options ABCD given. This is from engineering mathematics from the topic complex variables, subtopic complex integration or residues, which is 2 marks question. The solution is so first of all the curve is a circle with center 0 and radius 3. Curve C is mod z is equal to 3. The singular points or poles of this function is obtained by equating denominator to 0. Singular points of f of z are given by z square into z minus 2. That is denominator of the given integrand 0 implies z values 0 comma 2. So both lies inside C. When you substitute each point in the left hand side of the equation, that value is less than right hand side value. Right hand side value is 3, left hand side value is mod 0, mod 2. So both lies inside, both lies inside C. Also z is equal to 0 is a pole of order 2 and z is equal to 2 is a pole of order 1. Therefore, find the residue at each pole. RES means residue of the function f of z at z is equal to 0 is equal to limit z tends to 0 d by dz of z minus 0 whole square into f of z. So this is equal to limit z tends to 0 d by dz of, so this z minus 0 whole square is z square, which is cancelled with denominator one of the factor z square, one of the term z square. So finally this simplifies to sine pi z by z. So differentiation with respect to z, which is in the form of u by v, quotient rule, limit z tends to 0 z minus z in z minus 2 this is z minus 2 after cancelling z square in the denominator. So z minus 2 into sin z, sin pi z derivative is pi cos pi z minus sin pi z into z minus 2 derivative with z is 1 divided by z minus 2 whole square. So this is, now when applying limit z tends to 0, the numerator simplifies minus 2 cos 0 1, so pi cos 0 becomes pi sin 0 0 divided by 0 minus 2 whole square. So this is simplifies to minus pi by 2. Just here put z is equal to 0. Z tends to 0 means putting z is equal to 0. Next. And residue f of z at z is equal to 2, which is a simple pole. So residue is limit z tends to a, z minus a into f of z. A means 2, z minus 2 into f of z. So this is limit z tends to 0 sine pi z divided by z square z tends to 2. So sine 2 pi by 2 square 4 sine 2 pi value 0. 0 by 4 is 0. So therefore, by using residue theorem, Cauchy's residue theorem, the value of the given integral over C, f of z dz is equal to 2 pi j or 2 pi I, because in options j is given 2 pi j into sum of the residues at the poles in the inside the curve. So minus pi by 2 plus 0. This simplifies to minus pi square j. So this is the answer. Accordingly, the option is D. This is end of the question. The question is, consider the matrix 1 k 2 1 where k is a positive real number. Which of the following vectors is or eigenvectors of this matrix? Four options ABCD given. This is from engineering mathematics from the topic linear algebra subtopic eigenvalues eigenvectors. The solution is, so k is a positive real number given. So let us take an example of k, then find the corresponding eigenvalues and check which of the following options is eigenvector. Options is or are eigenvectors. Solution. Suppose k is equal to 2, a positive real number. 2 is a positive real number or not? Then matrix, given matrix A is equal to 1, 2, 2, 1. This is given matrix. So find the characteristic equation and find the corresponding eigenvalues. The characteristic equation EQ means equation is determinant A minus lambda is equal to 0 or lambda square minus sum of the eigenvalues into lambda plus product of the eigenvalues equal to 0 using that method also. Determinant 1 minus lambda 2, 2, 1 minus lambda equal to 0. This implies 1 minus lambda whole square minus 2 into 2, 4, 0. This simplifies to lambda square minus 2 lambda minus 3 is equal to 0. So, minus 3 into 1 minus 3 minus 2 can be written as minus 3 plus 1. So, which is exact factorizable. Lambda minus 3 into lambda plus 1 equal to 0, which implies lambda is equal to minus 1 comma 3 are the eigenvalues of given matrix A. Okay. So now denote each option, that is denote the vector in each option by x. Whichever satisfies Ax equal to lambda x, that is the required eigenvector. Option A, let x is equal to k is equal to 2. Okay. So this becomes 1 minus 1 root or 1. Okay. Since k is equal to 2. Okay. Implies a into x. A is 1, 2, 2, 1. X is 1 minus 1. So multiplied first row into first column 1 into 1 plus 2 into minus 1. 1 minus 2 simplifies minus 1. Second row into first column 2 into 1 plus 1 into minus 1 simplifies to 1. This can be written as minus 1 into 1 minus 1, which is in the form of, this is one of the eigenvalue lambda minus 1, and this vector is corresponding x. So this is satisfying x equal to lambda x. Therefore 1 minus root over 2 by k is an eigenvector like that. Option B, let x is equal to 1 root over 2 by 2, k value 1, implies a is equal to ax 1, 2, 2, 1, x value 1, 1. This can be written as first row into first column 3, second row into first column 3. This can be written as 3 into 1 comma 1, which is in the form of another eigenvalue lambda 3, and this is nothing but x. So therefore 1 root over 2 by k is an eigenvector in each option putting k is equal to 2. Okay. Now option C, root 2 into 2, k is equal to 2. So root 4 is 2. C is equal to 4. Root 4 is to 2, 1 capital X. Option C. Let x is equal to 2, 1 implies a into x. A value 1, 2, 2, 1. This is 2, 1. First row into first column 1 into 2 plus 2 into 1, 4. Second row into first column 2 into 2, 4 plus 1, 5. 4, 5. So this is not equal to any number lambda into x. Therefore, x is equal to root over 2k 1 is not an eigenvector. Option D. Here put k is equal to root over 2 into 2, root 4 2, 2 minus 1. So x value 2 minus 1. Implies ax equal to 1, 2, 2, 1, 2 minus 1. First row into first column 1 into 2, 2 into minus 1, 0. Second row into first column 2 into 2, 4, 1 into minus 1, 4 minus 1, 3. So this is again not equal to lambda into the given fourth option vector x. Therefore, root over 2k, root 2k minus 1 is not an eigenvector. So the answer is option A, option B are the eigenvectors of this matrix. This is end of the question.